Hello guys, welcoming you all. Today we are going to see about magnetic resonance in qualitative and quantitative analysis from nanoscience and technology. Resonance. Magnetic resonance is an analytical technique used to study type, number and position of atom in a molecule by using rotation of nucleus. It is often termed as nuclear magnetic resonance. Nuclear magnetic resonance spectroscopy based on rotation of nucleus in magnetic field, rearrangement in some orientation using electromagnetic radiation. Table of content. Principle of nuclear magnetic resonance spectroscopy, nuclear magnetic resonance spectroscopy, experimental setup, construction of nuclear magnetic resonance spectroscopy, working of nuclear magnetic resonance spectroscopy, advantages and disadvantages of nuclear magnetic response spectroscopy, application of NMR spectroscopy. Principle of NMR spectroscopy. Nuclear magnetic resonance spectroscopy is based on the following principles. Atomic nuclei with the add mass numbers possess magnetic moments. Number of protons are not equal to number of neutrons. Application of external magnetic field aligns nuclear spins. The spin quantum number of NMR spectroscopy is 1. It also based radio frequency pulse and signal detection. The diagram shows the experimental setup of NMR spectroscopy. Construction. A system consists of glass tube with 8.5 cm long and 0.3 cm in diameter. A homogeneous magnetic field at 60 to 100 MHz is made to control using magnet. A radio frequency transmitter coil is used to produce short, powerful pulse of radio wave in range between 4 to 900 Hz. Detectors are used to detect the radio frequency. The computer analysis are used to record data. Working of NMR spectroscopy. First, sample preparation. Sample dissolved in solvent and sample placed in NMR tube. Magnetization. Magnetic controller produces strong magnetic field which are used to rotate the nucleus in random manner. Nucleus spin aligns the orientation known as alpha spin. It is present in ground state of nucleus. The spinning of nucleus in ground state made towards excited state. This is known as beta spin. Radio frequency pulse. RF coil, which means radio frequency coil, transmits radio frequency pulse. It perturbs nucleus spins. Signal detection. Nucleus spin emitting signal can be detected by radio frequency coil. Signal processing. By applying Fourier transform, signal get amplified, filtered, and computer processes the data. Printers are used to record the data manually. Advantages of NMR spectroscopy. Structural elucidation. NMR provides detailed information on molecular structure. High resolution. NMR spectra provide high resolution information. Quantitative analysis. NMR signals are proportional to nucleus concentration. Versatility. NMR applies to various fields like chemistry, biology, medicine, etc. Dynamic information. NMR studies molecular dynamics and interactions. Non invasive. NMR analysis samples without physical contact. Multidimensional. NMR provides 2D, 3D, and higher dimensional spectra. Disadvantages of NMR spectroscopy. Cost. High field NMR instrumentation are very expensive. Sensitivity. NMR signals can be weak, requiring large sample instrumentation. NMR requires specialized maintenance, intensive instruments. Limited availability. High field NMR instruments are rare. Data analysis. NMR data analysis can be time consuming. Magnetic field sensitivity. NMR instruments requires stable magnetic fields. Operator expertise. NMR operation requires specialized training. Application of NMR spectroscopy. Structural elucidation of organic compounds. Protein structure determination. Study of molecular interaction. Metabolic profiling. Quality control in paramedical industry. More precise and accurate image used to study hydrogen bonding. Thanking you.